Well, in this episode we want to take a look at parallel circuits. So in the previous episode we learned about series circuits and how we had only one current path, how we added up the resistance to be total resistance or RT. In this episode we're going to take a look at a 12 volt circuit with a 6 ohm for R1 and a 2 ohm for R2. And we're going to figure out the total resistance of this circuit and what the current going through it is. The reason parallel circuits are just a little bit more difficult, you can't just add them up, because if we take a look here at our current paths, just like if we had two hoses flowing from a water source like our spigot, we actually have more than one path for current. Now, one thing to realize is whenever you have more than one resistor in a circuit, the total resistance will always be less than your lowest resistor. So we'll learn this, it's always going to be less than that lowest when you have more than one resistor in parallel. So the first thing we're going to look at is the formula for parallel resistance. Our resistance total is going to be 1 over RT, or total resistance, is equal to 1 over R1 plus 1 over R2. It can also be written like RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3, and etc. So as we look at this illustration, 1 over RT is equal to 1 over 6 plus 1 over 2. So as we add these up, it's just your typical fraction add in here. What we're going to end up with, if we use 6 for both, it's going to be 1 6 plus 3 over 6. So it's going to be 4 6, but it's the reciprocal. So it's going to be 1.5 ohms. I erased that. I'm going to rewrite it so I have more room to work down here. So 1 over RT is equal to 1 over R1 plus 1 over R2. So we rewrite that with this in mind. 1 over RT is equal to 1 over 6 plus 1 over 2. So 1 over R1 and 1 over R2, which is the same as saying 1 6 plus, we got to make that 2 compatible, so the same as any fraction when you're adding. So we end up with 4 over 6, but remember it's the reciprocal, so we end up with 1.5 ohms. So remember, we always have less resistance than our lowest resistor in parallel, so that we know that our RT is equal to 1.5 ohms. So now that we know our resistance total, we can figure out our total current. Don't forget this guy, Ohm's law. So 12 volts over 1.5 ohms. Let's draw that in blue. 12 over 1.5 is going to equal 8 amps. Well, that's going to be 8 amps total. But we know we have more than one path here. So what's the best way to figure out our current in each individual resistor? Well, it's pretty easy, because we have our 12 volts on each resistor. We actually know our resistance and we know our voltage, so therefore our current is easily derived. So this is going to be 2 amps. So 12 divided by 2 is going to be 6 amps. And we just confirmed, by combining those two, we confirmed that our total 8 amps is correct from our RT calculation. Just remember, in series circuits like we learned about last episode, every time you add a resistor, your resistance goes up. And just remember, in a parallel circuit, that each additional resistor or resistance added your total, your RT is going to go down. Sometimes it's hard to get your head around that, because I could come in and draw another line here. You could just add as many as you want, right? I could come in and draw a 1 megohm resistor. And you think a megohm, that can't bring the total resistance down. But yeah, a little bit it will, because it's yet another path. Even though it's going to be a little bit of current, it will be into the microamp. Any resistance added in parallel will reduce your total resistance. So one thing worth mentioning with parallel circuits I didn't go over earlier, because there is a formula. If you only have two resistances in parallel that you're wanting to calculate, you can use RT is equal to R1 times R2 over R1 plus R2, which will be similar here. We have R1 is 12 and R2 is 18, for example. We would just do 12 times 18 over 12 plus 18 gives us 216 over 30 equals 7.2 ohms. And the reason I didn't go with that to start with is I had two in that example. I didn't want that to seem like that's the only way to do it. Because if you had three or more in that same circuit in parallel, then you would have to use this one. So I just typically always use this one because it works for all of them. And when it comes to the reciprocal, if you have this button here on your scientific calculator for reciprocal, then it makes it easy once you do your calculation. So on mine, I have to hit the second function. So if I do 5 divided by 36, I can do it that way and do second function reciprocal, and there's my 7.2. So you can do it that way if you have the calculator, and it's easy. So I hope you enjoy this quick look at parallel circuits and the difference between parallel and series circuits. In the next episode, we will look at series and parallel combination circuits, which gets just a little bit trickier, but we actually solve them the same way. We just break them down and solve them based on the individual series and parallel that's left in the circuit. Hope you enjoyed this video on parallel circuits. If you liked the video, please give it a thumbs up. Please subscribe, and thanks for watching.